Hello, this is Dr. Arberg, and I'd like to welcome you back to our course, Introduction to Reinforcement Learning, Motion Control. And the topic of our lesson is the reward function of desired system performance. Now, let's take a look at what we get from Amazon about the reinforcement learning and the tools that they provide us to train ourselves with it. So in pole opposition to reinforcement learning, Amazon says that AWS Deep Racer, this is the Deep Racer car, gives you an interesting and fun way to get started with reinforcement learning. Reinforcement learning is an advanced machine learning technique that takes a very different approach to training models than other machine learning methods. Its superpower is that it learns very complex behavior without requiring any labeled training data, as we saw earlier, and can make short-term decisions while optimizing for long-term goals. And what Amazon is doing with the Deep Racer is actually international competitions. Folks are having an opportunity to train the car to drive a truck, and the one that does it at the minimum time is the winner. Very interesting. Now, let's take a look at an example of what we see here, how to determine the reward function for a specific task that is required from the Deep Racer. Now, this example follows the center line in time trials. The example determines how far away the agent is from the center line. This is being calculated and gives higher reward if it is closer to the center track, and encouraging the agent to closely follow the center line. So here's the reward function subroutine within the program. And here's an example of rewarding an agent to follow the center line. So we define the parameter. Track width is what's given in the system, track width. Distance from the center is also a machine parameter. And then we define for our reward function a variable marker 1 is the 0.1 of the track width. Marker 2 is 0.25, and marker 3 is 0.5 the track width. And then the reward function says the following: if the distance from the center is less than Mach 1, less than 0.1 the track width, then the reward is 1. If it's less than marker 2, 0.25, it's 0.5, and if it's less than marker 3, then 0.1. And then other than that, if the reward actually gets to be close to 0, when it is none of these options, meaning that it is greater than the distance, which is half the track width. So with that, we can see that there are higher desired performance requirements from the Deep Racer, such as the obstacle avoidance. So reinforcement decision under unexpected environment may require avoiding obstacles in autonomous system. And we see over here the truck, we see the obstacle over here, and we see over here the reward function that the agent of the Deep Racer is training it to avoid that obstacle. We see also that universities, Cambridge University in March 2020 published an article which is reinforcement learning based collision avoidance. and the impact on the reward function and the knowledge transfer. And what I personally did when I was teaching at Stony Brook, just before the COVID, a little bit afterwards, is actually to do a competition at the end of a course, running the deep racer and avoiding an obstacle, very similar to what we have over here. This was the mechanical engineering 634 at Stony Brook in 2020. And if you look closely, you'll see that I'm sitting actually right now on this chair, and you will recognize these two photos right in here. So with that, I'd like to thank you, and I look forward to talk to you in our upcoming lesson.